Hello, how are you? The title of today's video is
C# Tutorial 1 Update UI control from background thread in WPF with dispatcher. Here is a summary of the background knowledge that is directly related to the topic of this tutorial. 1. WPF is STA application. STA stands for Single-Threaded Apartment. 2. UI controls can only be created on STA thread. 3. A control can only be accessed on the same thread it is originally created. Since they are self-explanatory, I won't spend time explaining them. Instead, we will go through a WPF program to illustrate how they affect the behavior or require dispatcher class. I'm using Visual Studio 2017. Create a new WPF application. Select Template, WPF App using .NET Framework. The default .NET version is 4.5. Check Create Directory for Solution. Save to the location of your preference. Before we make any change, run the program with Ctrl F5. Make sure no problem. Right-click on the Source Code tab. Select Open Containing Folder. Look at the attribute for main in the folder Object Debug. Open automatically generated file App.g.cs. App is defined as partial class. The attribute for main method is declared as STA thread. This clarifies our first statement. WPF is STA single-threaded apartment application. There's nothing for us to modify here. It just helps us to understand better the nature of WPF application. Come back to Visual Studio. Open Toolbox with shortcut Ctrl+Alt+X. Add 2 buttons and 1 label to the main window design area. Now update their properties in Properties pane. Change the name of the label to LBL message and the text size to 72 pixel. Change the name of left button to BTN once, text size to 48 pixel, and the content to once. Change the name of right button to BTN continuous, text size to 48 pixel, and the content to continuous. Adjust the control size if necessary. That's all for our GUI design. Run the program and you shouldn't see any error. Double-click on buttons to add click event handlers. Now we have event handlers for both buttons, once and continuous. Add a class scope variable _count as integer and assign 0. It's optional to add private access modifier. It's default to private. Implement button once event handler. Increment count variable. Update message label with number of clicks. Run the program. Click button several times. The message is updated accordingly. So far, we are updating UI label control from UI thread. It works flawless. Now assume we want to call a long-running method to alternate label background color from red to yellow, back and forth every half a second. First, let's find out what could happen if this method is called in UI thread. Add a method to update label background. Accepting integer state as parameter. Use switch block to decide which background color is applied to label. Red when state is 1. Yellow when state is 2. This is a simple routine. Add another method without a better name. We call it long running to display the possible exception message that we expect will happen at some point in this tutorial. Add try catch block. Use message block to show the exception details. Use endless loop to simulate a long-running process. Set delay to 500 milliseconds. Call update label background method with argument 1 and 2 with interval as defined. Now call long-running method from button continuous event handler. How bad it could be. Let's run the program and find out. Click button once. It works as before. Now click button continuous. Do you expect smoke and flames? Actually no. The application is simply frozen, not responding. Try to close the program. It complains the application is not responding. Okay, that's understandable. We shouldn't block the UI thread with long-running process. Otherwise, bad things happen. Of course, there are some workaround, like using timer to alternate background color in the UI thread. But that's not what I want to focus on in this tutorial. We want to put this long-running process in the background thread. In C#, creating a new thread is simple. It just needs several lines of code like this. new thread with anonymous method and a lambda expression. Move long-running method inside. Explicitly specify this is a background thread. It's optional. Call start method using method chaining. By the way, you can also use task with long-running option for this example. As long as we can create a separate thread to host a long-running process, we are satisfied. That's all to run a long-running process in the background thread. Run the program. Click button once. It still works as before. Click button continues. What happens? The exception happened right away with message. The calling thread cannot access this object because a different thread owns it. In other words, the background thread cannot access the label control that is owned by the UI thread. The meaning is clear enough. So far, we're convinced that UI control can be accessed on the UI thread, but not directly from non-UI thread. The rest of this tutorial is to provide one way to update UI control from non-UI thread. How to solve this problem? Dispatcher class is the answer. The main purpose of this tutorial is to show how to use it to let background thread access the label control that is owned by the UI thread. Before we start using dispatcher class, let's understand how every WPF object refers to a single dispatcher. In this class hierarchy diagram, you can see that every WPF control inherits from dispatcher object class, which in turn inherits from base object class. When label control is created, it calls the protected constructor of dispatcher object, which contains a property of type dispatcher. The reference of current thread dispatcher is saved to this property. That's why a single dispatcher is used to handle the event queue in WPF single-threaded apartment. The same hierarchy for label control can also be viewed from Object Browser in Visual Studio. Open Object Browser. Search for label. Go to System Windows Control Label. Expand the node and drill down to see the inheritance architecture. Label, Content Control, Control, Framework Element, UI Element, Visual, Dependency Object, Dispatcher Object, finally Object. This is the same as we have seen before. When we create a new thread to offload the work and want to update UI control, like label control in our case, we must use dispatcher. Only dispatcher can access UI control from non-UI thread. In other words, the background thread must delegate the work to the dispatcher associated with a UI thread. The operation is added to the event queue of the dispatcher at the specified dispatcher priority if we decide to use priority. Dispatcher has two methods we can use: invoke for synchronous action and begin invoke for asynchronous. Asynchronous means the program flow control returns immediately to the calling object after it's called. Since we will use begin invoke in our example, let's take a closer look at one of its declarations. Here, the first parameter is a delegate to the method that takes parameters specified in args, which is pushed onto the dispatcher event queue. The args is an array of objects to pass as arguments to the given method. By the way, you can also specify the dispatcher priority, like normal, render. I will skip setting the priority in this tutorial, since their effects are not so obvious in our example. Without further ado, let's start fixing our problem with dispatcher. Back to our code. First, declare a delegate with name update label background callback to be used in dispatcher with return type void and one argument of integer. A delegate is like a function pointer in C or C++. Yes, there are some differences, but this is enough to understand our example. Go to long-running method, calling dispatcher, begin invoke, and wrap the original update label background method into delegate we just created. Then pass 1 and 2 as argument value. That's all we need to change to use dispatcher. It looks we spent much more time on explaining the theory than coding. Run the program. Click button once. It still works as before. Click button continues. You see, label background color starts alternating between red and yellow continuously. The dispatcher class enables us to update UI control from background thread. Here is a complete code. Part 1 with button once event handler. Part 2 with button continuous event handler. And update label background method. The essential code is in part 3 with dispatcher, begin invoke, implementation in long-running method. The complete program can also be found at GitHub with this link. Here is a brief recall of what we have learned. WPF is STA application. UI controls can only be created and accessed on UI thread. To access UI controls from non-UI thread, dispatcher must be used. Thanks for watching.